Using your eyes. X-intercept.
The x is 1
The X is 1, good.
and the y is 2.
And the Y is 2, exactly. So here's my Y-intercept. And down here is my X-intercept. So again, just like we talked about in the bell ringer, you always look at where the function is crossing the X-axis, where the function is crossing the Y-axis. So my X-intercept is 1. My Y-intercept is 2. Do I have any questions on how to find it on a graph? I don't want this to be confusing. I want to make sure this is the easiest thing in the world because it should be easy. So if you're still kind of like, you're not really sure how to do it, does anyone want to ask in the chat privately or out loud? Any questions? Okay. And just remember that on a graph, on a table, on a equation, anytime you have the x-intercept, that's where y equals 0. Anytime you have a y-intercept, that is where x equals 0. Okay, so graphs, easy. Equations. Equations are really easy for one of those, and you have to put a little bit of work for the other. So which of these is easy on an equation, the y-intercept or the x-intercept?
The X.
So just by looking at this equation, can you tell me what the x-intercept is?
No.
No. So x-intercept is the one you're going to have to put in work. But what about the y-intercept? Can you find that one easily?
The 6.
The 6. And not just 6, -6. Okay, so when you have a slope-intercept equation, it's pretty easy. You just use your eyes. You just look and you identify it. It's right there. But for x-intercept, it's not right there. It's not right in front of you. So this is a review from Friday's class. What do you need to do to calculate and find the x-intercept?
Replace the y with a 0.
Exactly. You're going to replace the y with a 0. Does anybody remember why we do that? I'll explain it, but I just want to see if anyone remembers why. Why would I plug in a 0 for y?
Because like when you plot it on the graph, Y is 0.
Yeah, that's exactly what we just talked about, right? Where on a graph, the x-intercept, here it was 1, 0, which means the input is 1 and the output is 0. So what I did here is I made the output 0 to figure out what the input would be. So that's why we do it, because anytime, like I said, anytime you have an x-intercept, that means y equals 0. Okay, so let's go ahead and solve for x. What do I do to both sides?
Add 6.
Add 6. 0 plus 6?
6.
6. 6 equals 1/2 x. And who can remind me, when you have a fraction, what do you do to both sides to get rid of it?
Divide by 2.
Multiply.
Multiply.
Yeah, multiply. Yeah, you guys got it. Multiply by 2. So here I'm going to multiply by 2 on both sides. And what that does is it completely cancels out my denominator. So that cancels out. And now I have 12 equals 1x. And we know that 1x is the same thing as just x. So x equals
16.
Oh, 12, sorry. I saw a 6 and I wrote a 6. All right, x equals 12. So my x-intercept is 12. Okay, and remember again, the y-intercept is -6, so that means that there is a point at 0, -6. And since the x-intercept is positive 16, that means there is a point at 16, 0. Any questions on calculating the x-intercept when you have an equation? Okay. And by the way, I just want to show you guys something really quickly. Let's say you forgot that the 6 in the equation is your x and your y-intercept. Like you just kind of forgot that. That's okay. What could you plug in to figure out the y-intercept instead?
X?
Yeah. If you have an equation and you're not sure where the y-intercept is, you can always plug a 0 for x. And I'll show you why it still gets you -6. If I plugged in a 0 for x right here, what would happen to that fraction?
It will cancel out.
It would cancel out because anything times 0 is 0. And so here, technically what I have is 0 minus 6, and 0 minus 6 is -6. So see, I still got -6. So if you get an equation where you're not sure, you can always plug in a 0 for x. And I think on the homework that I'm giving you guys tonight, you'll have to do that a couple of times. But it's super easy. All you have to remember is to plug in a 0 for y if you're looking for the x-intercept, plug in a 0 for x if you're looking for the y-intercept. Just plugging in zeros. Okay, so that's when you have an equation. So far we've done it on a graph, an equation, and now here's the tough one. Now we have a table. And on a table, the first thing you want to do is look at the table and see if there's any useful information. Does this one have any useful information?
No.
No, because what would you look for on a table? So let's say you were looking for the y-intercept. What would you look for?
The 0.
When x equals 0.
Yeah, you would look for 0 here, for this would be the y-intercept, and then you would look for a 0 over here for your x-intercept. So this would be your y-intercept, and then this would be your x-intercept. So since we don't have that, this is the one that's challenging, okay? This is the one where we're gonna have to take like 3 steps to figure everything out. Does anyone remember what is step 1?
Get the points.
Yeah, so you're gonna get 2 points. We're gonna choose easy ones, right? So which ones are my easy points?
The positive.
The positives. And when you choose your 2 points, what do you do with them?
You put it in y1 minus y2.
Right, so what's that called? Does anyone remember?
Then
Slope intercept.
The slope, not the slope intercept, but just the slope formula. So in other words, we got to find the slope before we can do anything else. So that's step 1. We're going to find the slope. And just like Lauren was saying, we're going to plug it into the formula. y2 minus y1 over x2 minus x1. So what would I plug in here?
36 minus 12.
Mm-hmm.
And then 12 minus 4.
Mm-hmm. All right, perfect. What do we got? 36 minus 12
24.
and 12 minus 4?
8.
8. And what's 24 divided by 8?
3.
3. So we got the slope. That's always the first thing you have to do, because if you don't know the slope, you can't figure anything else out. So that's why we do that first. So we find the slope. Now that I have the slope, which of those values could I figure out? The x-intercept or the y-intercept?
The y.
Yeah. Okay, and this is a review again from Friday's class. Does anyone remember what the strategy is for finding the y-intercept?
The slope intercept form.
Yeah, this is where you go for slope intercept form. So this is y equals mx plus b. And your goal is to fill in everything except for b. So what do you have to do?
You have
Pick
to
a
put 3 to
Yeah.
replace 1.
Yeah, so you got to pick a point from the table. Any of those works. Which one do you guys want me to pick?
412.
412. So I've got my 412 and I have my 3 for m. I'm going to plug all those things in because the 4 is my x, the 12 is my y. Oops, 12 is my y. We're going to plug x, y, and m straight in. So my y is 12, my m is 3, and my x is 4. And then plus b, because that's what you're looking for. And now we do some math. What's 3 times 4?
12.
Oh, cool. And if I wanted to get b by itself, what would I have to do to both sides?
Why is my question? Subtract 12.
Yeah, you're supposed to subtract 12. And usually you get a nice number, but here what happens?
You get 0.
You get 0. So my y-intercept is 0. So on the graph, where would the y-intercept be passing through?
The 0 point.
The
What's that called?
origin.
The origin, exactly. The origin. So this one was kind of easier than usual. Okay. So I have my slope, I have my y-intercept. I'm almost there. Now I just need to get my x-intercept. And who remembers what I have to do here?
You need to put the equation down.
Yeah. So before you find the x-intercept, we're writing the equation for this line. So since I have the m, since I have the b, I can simply write y equals 3x plus 0 in this case. So my y-intercept is 0. So really, since it's 0, I could just write y equals 3x. So that's the equation for this line. And now, since I'm looking for the x-intercept, what do I plug in and where?
Put
You plug in a 0 at the y.
You plug in a 0 at the y, good.
yeah.
So 0 equals 3x. Okay, this is a little weird, but let's see what happens. If I'm trying to get x by itself, what should I do to both sides?
Subtract 0.
Divide.
That one, yeah, divide by 3, because I'm trying to get x alone, right? So I would need to divide this by 3, but then what's 0 divided by 3?
0.
It's also 0. So as it turns out, my x-intercept is also 0. Which kind of makes sense, doesn't it? Because if I have a graph and it's passing through the origin, that means that the origin, like if I'm just going to draw a random line, if that's my function and it's passing through the origin, then the x-intercept is the same as the y-intercept because the origin is it's passing through the x-intercept and the y-intercept at the same time on the 0. So whenever your y-intercept is 0, the x-intercept is automatically also going to be 0. So this was a kind of like an interesting example, right? Because we found out, we had to do the work, but we found that out. But when you actually think about it, that makes a lot of sense, doesn't it? If it passes through the origin, then y-intercept and x-intercept both have to be 0. But do I have any question about this whole process? You guys told me what to do at every single step, so I'm very, very happy to see that we're remembering what we did on Friday and that we're kind of getting used to this 3 steps. So do I have any questions? Look through those numbers, make sure that you understand where all of them are coming from. Okay. All right, so now let's put this all together. Now that we know how to do this for a table, a graph, and an equation, we can compare two different functions. So can I get a volunteer to read this scenario? Dennis, what's Dennis doing?
Dennis compared the y-intercept of the graph of the function f of x equals 3x plus 5 to the y-intercept of the graph of the linear function that includes the points in the table below. What is the difference when the y-intercept of f of x is subtracted from y-intercept of g of x?
Awesome. So I have two functions. I have f of x, which is given to me as an equation. So that's f of x. And then I have g of x, which is this table. And in this case, we're going to be comparing the y-intercepts. So we're going to figure out the y-intercept for both of them. And then you're going to need to find the difference between them to get your final answer. So I'm going to give you guys about 5 minutes. See how much you can get done in 5 minutes. And if you have an answer, you can type it in the chat as usual, and I'll tell you if you got it right. So 5 minutes begin now.
Teachers and students, please pardon this interruption. Teachers, our clocks have not been reset, thus the bells are on the old schedule. At this time, please disregard the bells. We will be working the bells manually for the remainder of the day until our clocks are reset. Thank you and have a Jaguar Friday.
I was wondering why that rang. About halfway through. Okay, about 20 seconds remaining. Okay. So let's go through this together because I didn't get a whole lot of answers in the chat. So I'm assuming that we still have questions about it. So what am I trying to calculate for both functions? What's the only thing I need to worry about in this problem?
The y-intercept.
Y.
Yeah, only the y-intercept. So you can get the slope, you can get the x-intercept, but the only one we actually care about here is the y-intercept. So starting with f of x, what's the y-intercept for f of x?
5.
5, yeah. So for this equation, b equals 5. The y-intercept is 5. And that's it. I don't need to know anything else, so I'm going to stop there. I don't need to do anything else with that one. And then on this table, for g of x, if I need to know the y-intercept, what do I have to calculate first?
The slope.
Yeah, so first I can get the slope, and then I can find the y-intercept. So for slope, everything has negatives. Well, that's too bad. Sometimes that happens. But let's pick any 2 points. Which ones do you guys want?
-5 and 3.
-5, 3. And for the other point?
-3, 4.
Sure, let's do that. Okay, so since there's negatives, we're gonna have to be, very careful, but it's good. It's good practice because you never know. On a test, you might have that situation as well. So for the top, I get 4 minus 3. And then for the denominator, this is where you have to be careful. This would be -3 minus -5. If you didn't do the double negative, you would have gotten the wrong answer, okay? So does anyone have questions on why I did that double negative?
Miss, but like when you're subtracting the 4 minus the -3, isn't there parentheses too?
The 4 minus 3 on
Yeah.
in the numerator? No, because both of those values are positive. Since both of those are positive, you just plug them right in. There's no parentheses necessary. The reason I have parentheses for the -5 is to separate it from the minus sign.
Oh, okay.
Okay, so now that I have this double negative, let's rewrite it, because what do we know about double negatives? What does that turn into?
Positive.
Positive.
Yeah, so this is -3 plus 5. And now we can do our math. So 4 minus 3, that's 1. And what's -3 plus 5?
2.
2. All right, so my slope is 1/2. But that's not what I'm looking for. What am I looking for?
You gotta subtract
You have to divide it.
Okay, hold on. There were 2 questions. So I heard you have to divide it. I could divide it. I can also just leave it as a fraction. So I'm going to actually leave it as a fraction. What was the other question?
Are we gonna have to divide? I'm gonna subtract this.
So not yet, because what am I actually subtracting? I need to subtract the y-intercepts. But this is my slope, not my y-intercept. So this was only step 1. Now that I have...
them, are we gonna have to subtract it by other wires?
Yes, once we get them, yes. But we haven't gotten it yet. So now that I have my slope, what do I do to get my y-intercept?
You did the y-intercept formula.
Yeah, so I have to write down y equals mx plus b. And I'm going to plug everything in except for the b. So I need 1 point from this table. Any of these points works. Which ones do you guys want? Which 1 point?
-3/4.
-3/4. Okay. -3 is my x, 4 is my y. Here we go. So I have 4 equals 1/2 times -3 plus b. Okay. 1/2 times -3. What's -3 divided by 2?
Negative 1.5.
Yeah, negative 1.5. So I'm gonna write this as a decimal. That's negative 1.5. So 4 equals negative 1.5 plus b. What do I do to both sides?
Divide.
Well, if I'm trying to get b by itself, I'm not going to need to divide. What am I going to need to do?
Subtract.
Almost. It's already negative. This is a negative.
Add.
1.5.
Add.
Yeah, there you go. We add 1.5. Okay, cool. And what's 4 plus 1.5?
5.5.
5.5. So b equals 1 or 5.5. Okay, almost there. And like Bianca was asking before, now that I have everything I need to subtract them, because this is asking me, this is saying, what is the difference when the y-intercept of f of x is subtracted from the y-intercept of g of x? So what am I doing? Am I doing 5.5 minus 5, or am I doing 5 minus 5.5? Read it carefully.
You have to do 5 minus 5.5.
Okay, so here, let's read it again. What is the difference when the y-intercept, so the y-intercept of f of x has to be subtracted from the y-intercept of g of x?
So 5.5 minus 5.
So it's the other way, yeah. It's a little bit tricky, so this is just, you got to read very carefully. So 5.5 minus 5, what does that give me?
0.5.
0.5. So my answer is C. All right, that was a long question. I mean, it was a multiple choice question, so you kind of look at it and you're like, okay, it's multiple choice, that's going to be easy, right? No, you had to put in a lot of work for this type of problem. And I know for a fact that on the tests that they give you guys, this type of problem will there'll probably be like 3 questions that look like this, where you have to find the y-intercept or the x-intercept or the slope or all of those 3, and you have to take all the steps necessary to get that. So it takes a lot of work. That's why I wanted to really, 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 really practice all of this, because you just have to get used to putting in that work, okay? I don't want to see on a test, if you're working on this problem, your sheet of paper should be full of work. Do I have any questions?
I have a question. How do you know where to insert, like with the formula? How do you know what to insert?
For step 1 or for step 2?
For step 2.
For step 2, okay. So the formula tells you what goes where. So remember, you had to pick a point. So on the table, I picked -3, 4. The -3 was my x and the 4 was my y. So in the formula, take a look. Look, for the y, that's where I put 4. For the x, that's where I put -3. And then for the m, why did I put 1/2?
That was the slope.
Yeah, because we had gotten 1/2 in the previous step. So that's where everything lines up exactly where the formula tells you to put it. You just have to pick a point, and then the slope, you already calculated it, so that's why we use that number. Is that cleared up?
Yeah.
Awesome. Any other questions? Okay. Okay. So let's go ahead and now we're going to do a very similar problem, but this time I have a graph, and the graph, excuse me, the graph is a real world situation. This is actually the same one that we had in the bell ringer. So we've actually already done half of the work we need to do for this problem. So let's go ahead and take a look. So the equation d equals -1/2 t plus 6 models Jeremy's distance in kilometers from school along the bus route after t minutes on the bus. So this equation is for the bus. the graph models Jeremy's distance in kilometers from the school along the bike route after t minutes on his bike. So the graph represents his distance on the bike. Okay, so we're looking at two different situations. In one situation is when he's on the bus. On the other situation is when he's on the bike, on his bike. And the question is asking us three things. It's asking us which function has the greater rate of change, which function has the greater y-intercept, and which function has the greater x-intercept. So that means I need to know those things for all three, or for both of the situations, for the bus and for the bike. So since we already did the bike, let's just remember what we got. So for the bike, we had calculated the slope, and we had figured out the y-intercept and the x-intercept. So can anybody remind me? This is just the same thing as the bell ringer. What was the slope?
1 out of 2.
Close. It wasn't one
Negative
half.
1/2.
It wasn't 1/2. You guys are close though. It was one.
Negative.
Yeah, it was -1 over
4.
4. Yeah, -1 over 4. What was the y-intercept? And if you don't remember, you can just look.
4.
4.
4.
Good. And what was the x-intercept?
16.
16. Okay. So that's all. We already know this. This is good. So all we need to do now is figure out the same information, but for the bus. So for the bus, I have an equation. And even though I have different variables, this is still slope-intercept form. This is still y equals mx plus b. It's just that they're using d and t instead of x and y, but it still means the same thing. So in this case, what would be his slope? What would be his slope? There's no math necessary. This is an easy question. What's his slope? I'm serious, guys, no math. Just look. It's in the equation.
Negative 4. I mean, no. Negative 1/2.
Yeah.
For the.
Yeah, for the
And then
slope
6.
is -1/2. And the y-intercept is +6, exactly. Okay, because remember, y equals mx plus b tells me that whatever number is next to the x is my slope, and then whatever number you're adding or subtracting is the y-intercept. So all you had to look at the equation and notice that -1/2 is the slope and 6 is the y-intercept. So there's only one thing I'm missing, which is the x-intercept, but we know what to do. What do we do when we're looking for the x-intercept?
The y-intercept form.
And what do I plug in? What do I do?
Plug in a 0.
Plug in a 0 for x, or for y, I mean. Now, let's see, I'm running out of room, so it's going to be a little bit, I'm going to write it in the middle over here, even though I'm just going to use that space for my work. So I have this equation, d equals -1/2 t plus 6. I'm replacing, which one am I replacing with 0?
D.
D, good. So 0 equals -1/2 t plus 6. Okay, again, I apologize that I'm kind of writing in the middle of the page, but I forgot to put in some space here. All right, if I'm solving for t, I want to get t all alone. What do I do?
Subtract 6.
Subtract 6. And what is 0 minus 6?
-6.
-6 equals -1/2 t. And what should I do to both sides? I have a fraction.
Divide.
Not quite, because remember, division, fractions are division. What do I do when I have a fraction?
Divide by denominator.
Close, Bianca, not divide, but
Divided the denominator by the whole thing.
so in other words, what operation should I use?
Multiplication.
Multiplication, yeah. Okay. So I'm multiplying, and I want to multiply by the denominator. Okay, so since my denominator is 2, I'm going to multiply by 2. But even better, I have a negative fraction, and I want to get rid of that negative as well. So I'm not just going to multiply by 2, I'm going to multiply by negative 2. Okay, I'm going to multiply this whole thing by negative 2, and then negative 2 on the other side as well. Okay, so again, I'm doing that to eliminate the fraction. Anytime in the whole world, if you got a fraction, multiply by the denominator. So that cancels out my fraction, and the only thing that I'm left with would be 1t. Now over on the left side, what's negative 2 times negative 6?
12.
12, good. So I know that t equals 12, which means my x-intercept is 12. So I've got all the information I need for the bus and for the bike. Any questions on how I got those answers before we answer the actual problem? Because I'm going to erase all this work. Okay, I'm erasing so we can answer. Which function has the greater rate of change, the bike or the bus?
The bus.
Bus. The bus is -1/2. Bike is -1/4. So bus is a little bit bigger. Which function has the greater y-intercept?
The bus.
Also the bus. Which function has the greater x-intercept?
The bike.
The bike.
Good. Okay. Well, that's great, but I have a real world scenario, right? So all these numbers actually have a meaning and actually tell us something, tell us information about Jeremy's travel to school. So let's ask some different questions now. I'm going to rewrite everything we had here. So for the bike, m was -1/4, b is 4, x-intercept is 16. Just rewriting it. For the bus, we had -1/2. The y-intercept was 6, and the x-intercept was 12. Okay. So with all that information in mind, which mode of transportation goes faster, and how do you know? Think about what those numbers actually mean.
The bus.
The bus. Bus goes faster. How do I know this?
Because the M
Good. The m,
is bigger.
the slope is greater. Don't forget, what does slope mean? Slope represents, in this case, and any time, remember what I said at the bell ringer. If you have time and distance, the slope represents the
Speed.
speed. Slope represents speed. So the bus has a greater speed. It's as simple as that. Whichever one has the greater slope goes faster. And you can also think about it like, okay, that kind of makes sense, right? The bus is probably going to go a little bit faster than the bike. But you have to back up that information, back up that fact with some information from the actual problem. So yes, the bus goes faster because the slope is greater. Slope represents speed, so the bus has a greater speed. Questions on that one? Awesome. For B, which mode of transformation travels a longer distance? Longer distance. And again, I'll write everything again. I know I wish it like copied onto the next slide, but I just have to manually rewrite it. So while I write it, think about it. Which one travels a greater distance?
The bus.
The bus travels a longer distance. How do you know?
Wait. Yeah, because it starts at 6,
Mm-hmm.
so it has more. Yeah,
Yeah.
because
So which value were you looking at? The slope, the y-intercept, or the x-intercept?
the y-intercept. Y.
Good. It has a greater y-intercept. And what does the y-intercept represent?
The distance.
The
The,
distance. And more specifically, the distance at the beginning, the distance at the end, the distance in the middle. What is it?
at the beginning.
At the beginning. So the starting distance. The y-intercept represents the starting distance, and the bus has a greater starting distance. Maybe, I don't know, maybe his bus stop is farther away. Maybe the bus route is just longer because it has to take more turns. Who knows? But either way, the bus has to start from 6 kilometers, whereas the bike is only 4 kilometers away. So the bus has to travel a longer distance. Questions on this one? See how we're putting it all together? Like these numbers actually mean something to us. So it helps us to answer questions about the actual situation. All right, so then finally, which mode of transportation arrives to school first?
The
The bus.
The bus. And why do you say that? What was that? 12, right? Yeah, 12.
Because the
x is 12, so it's
Because of the 12.
Yeah, so the x is 12, the x-intercept is 12, which, what does that represent?
Time. Minutes.
Good. So the bus arrives first because the x-intercept is not greater this time, but his x-intercept is smaller. The x-intercept represents not just the time, but the total time. And the bus takes less time. Okay. All right, so see, we were able to get a lot of information from the slope, from the y-intercept, and from the x-intercept. And that's really, really powerful. That's awesome that you can be able to figure out all of that just from an equation and just from a graph. Do I have any questions on this whole problem? We're going to do a few more that are very similar. So any questions right now will help everybody else out. Cool. Okay. So sometimes, and definitely on tests, but in general, you're going to be given a word problem. And from that word problem, you have to write an equation. It's actually really, really easy. So I wanted to give you guys a couple of examples. before you guys try it on your own. So could I get a volunteer to read the first example? Who can read for us?
A department store offers a frequent buyer's card to earn rewards for purchases customers make at the store. Each transaction is worth 12 points, and customers automatically earn 25 points when they sign up.
Awesome, thank you. All right, so I'm going to highlight a couple of things. I'm going to highlight each transaction is worth 12 points, and then automatically earn 25 points when they sign up. When you read a word problem, you want to identify two things, okay? First of all, we're going to look for keywords for slope. And then we're going to look for keywords for y-intercept. Now remember, I'm going to go back for a second. In this problem we were working on, what did the slope represent for this situation when we were riding a bike and a bus? What did the slope represent?
The distance? No. The faster it goes.
Right, so at how fast
The
it goes.
Speed, actually, like the speed.
Yeah, so the speed, exactly. So in this case, the slope represented the speed. And remember what I said, that whenever you have any sort of real world problem where it's measuring distance and time, the slope is going to be the speed. So if anything about a car, anything about a bus traveling, anything like that, you're talking about speed. But is that what I have here? Am I on a car or a bus or a bike or something like that?
No.
No. So instead, when you have a situation that isn't speed, you're always going to look for a few keywords. And here's the most common keywords that you're going to see for slope. I want you guys to write this down. For slope, there's 3 magic words. Ready? We got per, each, and every. Per, each, and every. And we can think about it. We've actually seen that before. Remember how anytime I ask you for the units for slope, it's always like blank per blank. We always talked about how it's 2 things and we're comparing them. So there's always a per in between. So per, always look for that word. And then each and every are just like they're synonyms for per. They all mean the same thing. So you could think about, like, instead of saying miles per hour, it would be miles each hour or miles every hour. Those are all kind of mean the same thing. So in this word problem, what do I have? What's my keyword? Which one do you see?
Each.
Each. So bingo, right there, I see my each. So I know that my slope, I look for the number that's connected to that each, to that keyword. I know that my slope is exactly, it's 12. And then y-intercept. Y-intercept is a little bit different. You're not always going to have like a specific keyword, but you can always remember, if I go back over here, my y-intercept was the starting distance, right? In this case, it was how far they started from the school. Well, you're always going to look for anything that's like the starting amount, initial amount, anything that tells you that that's where you begin. So starting amount, initial amount. But again, they might say this a lot of different ways. So in this case, what do they say to indicate that we're starting with 25 points?
Like when they sign up, when they first sign up?
Yeah, it tells you that that's what you get when you first sign up. So that's kind of how they tell you that this is the y-intercept, 25. All right, so now I have my slope. I have my y-intercept. I can write my function. or my equation. And in this case, I could write y equals 12x plus 25. And that's it. So with any type of word problem, those are the steps we're going to take. You're going to read it carefully, identify those keywords, figure out which one's the slope. It's always going to give you two numbers, right? So you have to identify which of those numbers is the slope and which of those numbers is the y-intercept, put it all together and write your equation. So let's do one more together and then I'll have you guys do a couple examples on your own. Would anyone like to read this one? I know you guys have been participating a lot and I'm proud of you for that. So I don't mind reading this one if nobody wants to step up.
Andrew wants to buy a smartphone that costs $500. His parents will pay for the phone and Andrew will pay them $50 each month until the entire amount is repaid. The loan repayment represents the linear situation in the amount y that Andrew owes his parents is dependent on the x of the payment he made.
Perfect. Thank you, Bianca. All right. So who can tell me which one is my slope? Which one is my y-intercept? Look at those keywords.
$50
$50 is
slope
the slope. Good. What keyword does this one have?
each.
Also each. So we know he's paying $50 each month. And then I know that the y-intercept kind of or process of elimination, whichever one is not the slope, that's going to be your y-intercept. So here it's 500. Okay, but now let's actually think about this because something is a little bit different here. Andrew is paying back $50 each month, right? So he starts off, he's owing money. He's not gaining money, he's owing money. All right.
So is it gonna be negative?
So it's a negative.
Yeah, so it's going to be negative 50. Exactly. Good job, guys. So sometimes you really have to okay, you know the two numbers, that's cool, but you also have to think about, am I earning or am I losing? And here we're losing, so it's going to be y equals negative 50 x plus 500. All right, so here, those are two examples. Let's see now how much you guys can do on your own. I'm going to give you guys 3 examples on the next slide. So before you do that, do I have any questions? All right. Go ahead and give it a try. There's 3 examples. I'll give you guys a good 5 minutes to start. And then if you need a little bit more time, I'll give you more time. You don't need to write these down. That's going to take too long. So just read them off the screen and then write down the equation.
Miss, I forgot the keywords.
Here, I'll go back really quickly. Make sure you write down those keywords for slope. Take a picture now. That way I can move on to the other slide. Okay. Go ahead. 5 minutes. Okay, about 1 minute left. Do you guys want a little bit more time? Does anyone want a little bit more time?
Yes, miss.
Okay, I'm gonna add 2 minutes. So remember, we're identifying the slope, we're identifying the y-intercept, and then you write an equation from those two numbers. Okay, about 30 seconds remaining, and then we'll go over it. All right. Okay, let's take a look. For A, John gets a new job and receives a $500 signing bonus. After that, he makes $200 a day. Which one's my slope? Which one's my y-intercept?
$200
Is the
slope.
good, is the slope. Now, in this case, it didn't have the key words, but think about it this way. If I make $200 a day, that's the same thing as making $200 per day, or $200 each day, or $200 every day. So don't get thrown off if you didn't see the keywords, because you always want to look for synonyms as well. All right, so that was my slope. What was my y-intercept?
For A, I think it was 500.
Or 500. So this one was pretty simple because there were only two numbers there. There was nothing trying to throw you off. Very simple. The slope is 200 and the B was 500. So what's my equation?
Y equals 200x plus 500.
Perfect. Y equals 200x plus 500. Beautiful. Okay. For B, Jennifer is 20 miles north of her house and she is driving north on the highway at a rate of 55 miles per hour. What's my slope?
55.
55, which means my y-intercept is 20. And now just to make sure, because you always want to make sure if it's going to be positive or negative, is she getting further and further from her house, or is she on her way back? Read it carefully.
Further away.
Good. How do you know she's getting further and further?
He says she's on the highway.
Mm-hmm. More specific.
I'm just 20 miles north of her house.
Right. So if this is her house, and she's right here, this is 20 miles north, what direction is she driving? I see. Yeah, I see Karina put it in the chat. She keeps driving north, so she keeps going the same direction that she was already going. So that's how you know she's getting further and further. If she was coming back, that would be a different situation. But here she keeps going the same direction, so we know that she keeps adding distance. She's not subtracting, she keeps gaining more distance. So everything is positive. So miles per hour is my slope. 20 miles is my y-intercept, so y equals 55x plus 20. Boom, done. A and B were a little bit simpler. C has a lot more information, so we're gonna make sure we're not being thrown off because there's a lot of numbers here and we have to identify the correct ones. All right, so I'm gonna go ahead and read it. A figure skating school offers introductory lessons at $25 per session. There is also a registration fee of $30. Write a linear equation in slope-intercept form that represents the situation. You want to take at least 6 lessons. Can you pay for those lessons using the $200 certificate? If so, how much money, if any, will be left on the gift certificate? If not, explain why not. So there's kind of a lot going on here, right? But before we kind of get into it, let's just start by, I'm going to highlight all the numbers I see. So I see $25 per session, registration fee of $30, 6 lessons, $200 gift certificate. Which of all of those is my slope?
25.
Good. That one was easy because it has a keyword. We see per, so that one is very straightforward. But now I have a lot of different numbers here, and let's think about it. Which of those is my y-intercept?
I think it's 30
Okay, and why do you say it's 30, RL? You're correct.
because of the registration, like you have to pay 30 first.
Right, and remember, for y-intercept, we always want to look for the starting amount. So a registration fee, this is a very common thing to see in a word problem. Registration fee is when you pay something up front. So like if you're, I don't know, if you're signing up for like a gym membership or I don't know, like classes like this. Okay, sometimes you have to pay a registration fee and then you pay a certain amount each month. So this registration fee, that's the y-intercept because that is my starting amount. Okay, so that's all I need to write my equation. So I'm going to go ahead and write it. This would be y equals 25x plus 30. But then it's asking some more questions. So now that I have the equation, I'm going to use that equation to figure out the rest of this problem. So it's saying you want to take at least 6 lessons. Can you pay for those lessons using the $200 gift certificate? So I have this equation. Remember, equations are great because they help us to find answers to some problems. So since I have this equation, what should I plug in to figure out how much 6 lessons are going to cost?
The 6.
6.
Yeah, we're going to plug in a 6. Which one should I plug it in for x or for y?
X.
You are going to plug it in for x. Remember, again, this all goes back to functions. X is the input and y is the output. So my input is how many lessons I take, and the output is how much money that's going to cost. Another way that you could think about it too, remember that the slope is $25 per session? And whenever you have the word per, whatever it is on the left of that per, that's the y. Whatever you have to the right of it is the x. So 25, the money is y, the number of sessions is x. There's a couple of ways to think about that. Whichever one is more helpful, good, go for that one. But basically, we're plugging in 6 to figure out how much money it's going to cost. So this is 25 times 6 plus 30. What's 25 times 6? You can use a calculator. 25 times 6.
150.
150. Good. 150 plus 30 is 180. So it'll cost her or it would cost me $180. So what's the answer to this question? Can I pay for those lessons using my $200 gift certificate?
Yes.
Yes. You'll have $20 left.
$20 left. Could I take one more class?
No.
No, because how much is each class?
25.
25. Nice job, guys. All right. Awesome. We have 10 minutes left. We'll do this question and then we'll be done. Okay. So now that we know how to write an equation when you have a word problem, we're going to do another problem where we compare two different functions. So here I have my scenario. Jeff, an electrician, had a job that lasted 5.5 hours, during which he earned $32 per hour and charged a $25 service fee. The function j of t represents the amount Jeff earns in t hours. Okay, so I have this word problem. I'm going to write an equation so that I can answer all of these questions. So they're telling me that this function is called j of t. And remember, I need to identify the slope and the y-intercept. So reading carefully, there's a few different numbers here. Which of those is going to be my slope?
32.
32. Which one is my y-intercept?
25.
Good. Good, good, good. In this case, the initial value or the starting amount is the service fee. Because again, that's very similar to the previous problem where it had a registration fee. A service fee is kind of like you have to pay that first and then you pay whatever the rate is. Okay, so now I can write my equation. J of t equals 32 t plus 25. And I'm using a t instead of an x because it's telling me to use the t. Since it told me to use j of t, I knew that the input had to be a t, not an x. Don't worry too much about that. You won't really need to like do that on your own in the future. Usually it just tells you. Okay, so that's Jeff. And then we have Brendan. Brendan also works as an electrician. The graph B of t shows the amount in dollars that Brendan earns as a function of time in t hours. So for Brendan, we have a graph. For Jeff, we had this nice equation that we wrote. And for Brendan, we have a graph. So on this graph, I will also need to identify a few things. So what can I identify from this graph? What are two things that I know? Or what's one thing that I know?
The y,
Yeah, what is my y-intercept?
40.
40. Right here. What is another thing that I can calculate?
The slope,
The slope. So let's do that together. Pick another perfect point. Who can identify a perfect point?
2 and 100.
2, 100. All right, so I have 0, 40 and 2, 100. Go ahead, take 1 minute to calculate the slope using whichever strategy you prefer. Go ahead. Try it on your own, calculate the slope.
Is it 30?
30. How'd you get that?
I did the y2 minus y1.
You did the formula?
Yeah.
The formula, yeah, good. You should get 30, exactly. If you plug it in, this would be 40 minus 100. Wait, other way around, my bad. 100 minus 40. 100 minus 40 over 2 minus 0. 100 minus 40 gives me 60. 60 divided by 2, that's how we get 30. Okay, so I've got the slope, I've got the y-intercept, and then let's go back to that equation we wrote for Jeff. We also know the slope and the y-intercept right here. So now we have all the information, hopefully all the information we need. Let's go ahead and try and answer these questions. A, which electrician charges a greater amount per hour? Jeff or Brendan?
Brandon.
Brendan, how do you know?
Because of the slope.
Good. Brendan has a greater slope. Okay, cool. Which electrician has a greater starting fee?
Brendan.
Jeff.
Starting fee. What's the starting fee for Jeff?
Is 25.
25. Yeah. What's the starting fee for Brendan?
30.
Starting fee.
40.
40. Yeah. I kind of wrote them like backwards, but yeah, for Brendan has a more expensive starting fee. Greater y-intercept. Okay. Elise needs to hire an electrician to work for 3 hours. Which electrician should she hire and why? What do you guys think?
Jeff.
Probably Jeff. Why do you say that?
Because you don't have to pay that much. Brandon has a greater starting fee and a greater slope.
Right. So in every part of this so far, Brendan seems to be more expensive. So in this case, it's kind of obvious, but let's actually use some math to find out, and we'll be almost done, guys. So for Jeff, we need to see how much he's going to cost for 3 hours. So in other words, I'm going to plug in a 3. So we're going to plug in a 3 and see what you get. All right, what is 32 times 3?
96.
And then 96 plus 25?
121.
121. So for Jeff, it costs 121. And then for Brendan, I'm going to look at my graph. If he's working for 3 hours, okay, that seems to be pretty much right in between 120 and 140. So this seems to be about how much? I'll zoom in. It's between 120 and 140.
130.
130. So from the graph, we can figure it out that he's going to be more expensive. So Brendan, or so she shouldn't choose Brendan, right? She should
Yeah.
choose, yeah, Jeff. Jeff is cheaper. All right. Nice job today, guys. I'm very happy with the participation I heard. You guys were really working hard today. I skipped one question, but that's okay. There is an assignment on Khan Academy, just one assignment, and that one is going to be due on Wednesday night, okay? So I haven't put it up. I'm going to put it up right now. Make sure that you work on that. And, oh yes, I'm going to go ahead and put this up on the board. Take a screenshot if you want to get some extra practice. This is a really good problem that came up on a test a couple years ago. So, it's always good to practice those test problems because they're very similar each year. So we want to get a good practice in. Do I have any final questions before it's time to go? All right. Good job today, guys. I will see you tomorrow. Have a great, I won't see you tomorrow. No school tomorrow. It's a teacher planning day. So I'll see you guys on Wednesday.
I thought it was election day.
It's election day, yeah. So for teachers, it's a planning day, but it is election day. So make sure, parents, relatives, go out and vote. And I'll see you guys on Wednesday. Bye, everyone.